Assalamu alaikum. Now again the lecture continuation of the previous lecture, the topic application of first order linear ordinary differential equation. In last lecture we discussed the growth and decay model in detail, and we discussed about also the logistic exponential growth model. Now we consider some model belongs to the electrical technology or electronics or telecom, and definitely the electronics and electrical machine will also use in industrial and manufacturing technology, because machine will work with respect to the use of the electricity. Whenever they talk about the electricity, so electrical circuit will come, and how the model of electrical circuit in the form of differential equation. You previously study application of linear algebra, and we discussed the electrical circuit in the form of model of linear algebra. Now here we discuss the electrical circuit model in the form of first order ordinary linear differential equation. So well known standard model, and I think maybe you study in some particular course or in uh, any subsidiary topic, the RL model, RL circuit, RL circuit, application of ordinary linear differential equation, and the model is RL circuit. RL circuit means RL E of t. R, capital R means resistance, L means inductance, E voltage, EMF. RL circuit. Now use of the Kirchhoff voltage law, how the model will form by using Kirchhoff voltage law. The situation, voltage across the resistor, voltage across the resistor is equal to IR, and voltage across the inductor is equal to L di by dt. So voltage across the resistor I is current, R is resistance, and voltage across the inductor is equal to L di by dt. The rate of the current with respect to time, T is the time, L is the inductor. The change in resistance and change in inductance is equal to this. Then applying Kirchhoff voltage law. Kirchhoff voltage law, L di by dt plus Ri is equal to E of t. Kirchhoff voltage law, change in inductance plus change in resistance is equal to total voltage E of t. So this is all about formation of model RL circuit, and this formation of model identify by first order linear ordinary differential equation. Now the question, identify the type of first order linear differential equation. Just like in our previous model, exponential growth model identify by first order linear ordinary differential equation, the form separable variable, the first form separable variable, and we solve by using the technique of separable variable. Now here the situation is not separable variable because variable I and t, current and time, so you cannot separate I and t with respect to time and the current, because you change this to the right hand side, then involving the current at the time, then how you separate this with respect to operator di and dt. And if you think about the situation of homogeneous, then you write di by dt is equal to E of t minus Ri upon L. So we cannot think about the variable because variable is not defined in terms of particular situation. So how I identify in case of the homogeneous, because the variable involving the E function of time and I and the resistance Ri, Ei, Li, it's not easy to identify. Maybe some particular situation it become homogeneous, and the situation of again the not non-homogeneous, generally we think about the situation, but some constant term is not involved. The non-homogeneous situation involve x power 1, y power 1, here the variable I and t, I power 1, t power 1, but the constant terms is missing. Actually match with respect to the particular situation homogeneous. Maybe it is solved by the homogeneous situation. Then We cannot think about this general form about the exact or non-exact, but this directly think about the situation of linear. The simplest or easy situation is linear. In case of the linear, if you identify the general, recall the general term dy by dx, p of x, y is equal to q of x. So y and x. Now here y is equal to I, current, and x is equal to t. So by considering this general form, you can write this as di by dt, divide whole equation by L, R upon L, then I is equal to E of t upon R. Now comparing this equation, so this becomes E of t, function of time, E of x, then I instead of y, then function of t. So this is our q of t. Here integrating factor e power integral px dx. Here integrating factor e integral r upon L dt, r upon L dt, integrating factor. So equation identified by journal form, which is linear differential equation, and you can easily solve by the idea of linear form. Multiply whole equation by this factor e integral r L dt, then di by dt, then plus e r upon L dt, then r upon L I, and is equal to e upon r, and then e integral r L dt. So left hand side become d by dt integrating factor r upon L dt, and I, dependent variable, is equal to e upon r integral r L dt. Then equation separable variable, and the situation become e r upon L dt I, and then integral of this e upon r L dt plus constant of integration, and then you can find current at any time t. Shift to the right hand side by considering minus sign RL dt, then multiply E RL dt plus C E minus RL dt. Plus C E minus RL dt. So you can easily find the quantity of current at any time t. So this is general solution, the formation of the model, then general solution. In previous model, first we consider from the general phenomena formation of model, then second solution of the model, then third the particular application. In the same way, we consider RL model, then by using the basics physics law, the change in resistance, change in inductor, then by Kirchhoff law, how the total voltage equating the change in resistance plus change in inductance. Then we have first order linear differential equation, the sixth form, which is linear form. So this is linear in I, just like our general form linear in y, dy by dx plus pxy is equal to qx. This is linear in I, where I is current. So in mathematics we use general y and x, but in circuit theory our parameter change from yx to current, resistance and EMF, voltage. So we discuss formation, we drive the formation, and we find the general solution of RL circuit. Now we consider the particular problem in which how to find the current at any time or to find the current at particular time. So problem particular example, an RL circuit has an EMF of 5 volts, a resistance of 1 Henry, and no initial current. Find the current in the circuit at in the circuit at any time t. Now data show that we use RL model, not the exponential growth model, because data involve resistance and inductance. So definitely you will think about RL circuit model, not exponential growth model, not RC circuit, not the Newton law of cooling or some other model, because the parameter fit in RL model, because the information of capital R and capital L involved. So first write the situation, the data E is equal to 5 volt, R is equal to 50 ohms, R is equal to, where is R? A resistance of, not a resistance of 50 ohm. I forget to write the one sentence. A resistance of 50 ohms and inductance of 1 Henry and no initial current and no initial current. So please correct the question. I forget to write the information of resistance, just skip some words. An RL circuit has an EMF of 5 volt, a resistance of 50 ohms, an inductance of 1 Henry and no initial current. Find the current in the circuit at any time t. Now E is equal to 50 volt, 5 volt, R is equal to 50 ohms and L is equal to 1 Henry. So this information involved in our question, E, then capital R, then capital L. So the question from the word problem, how we fit the model. After the information in terms of notation, write the information, then you think about the model. So apply the model where all these information match and one of the unknown involved. So after fitting these information, so you basically find the fourth parameter, which is the current. So it's very easy to identify the model in which you apply corresponding to word problem. So first find out the parameter and then where all these parameters fit in our list of model. So you will think about the model, so you can easily think the model Our model RL circuit involve four parameters: resistance, inductance, current, and voltage. The three parameters are given, then you can easily find the fourth parameter, which is current. If instead of inductance we have the conductance R, then E, then C. So basically this model belongs to RC circuit. So we use the model of RC circuit model. Now here we use the model RL circuit model. So this is the answer of your question in examination, how I identify the model with respect to the problem. So it's very easy. From the word problem, first write the parameter in terms of a standard notation, and then you follow the list of the model, and then your information or the parameter match with any one of the model, then use the model. Definitely if C is not given, then how you use the model which involve the conductance. Similarly, how I apply the exponential growth model, because in this word problem, no information about the quantity. The time is given. Of course, the time always involved because of the rate, but here the current. So current is not the general quantity. So how you use the apply, and what about the thing about the voltage and the resistance? Only one quantity you can consider current as the quantity and the time, but what about the other parameter? Because exponential growth model involve only two information, the time and the quantity, but here you consider the time and the quantity, but situation involve the resistance, the voltage. So how you put the voltage and resistance, and by not using such type of quantity, how you identify the current. So this is the answer of the question, how you identify the model with respect to the word problem. So this is the information: voltage, resistance, current. Now we are not using here the direct general solution, just like in the previous problem. We had, find out the quantity of mass of the material with respect to any time, or the half of the mass of the material, then find the time by using directly the general solution. You can use the general solution also, but generally we use the general formation of the model, and substituting in the initial model the information, and then solve by technique of the linear differential equation, not by directly substituting the general solution. You can use, but the general solution you observe involve the complicated situation involving the integration uh, with respect to the power of the exponential, then negative, then divide. So it is easy to use the model of circuit L di by dt. It does not involve such type of complicated situation. You solve simply linear form of the first order linear differential equation E. E, of course, the function of time. Then substitute all values. L 1 di by dt plus R 50 I, then E is equal to 5. Then no need to divide the whole equation by 1. Our standard linear form dy by dx consists of coefficient 1. So it is just to show you L is equal to 1. Otherwise no need to write 1. So this is our standard linear form. then this 50 is equal to P of t. Then find integrating factor e power integral 50 dt. 50 is constant, so e just 50t. This is integrating factor. Then multiplying whole equation by E50t, L E50t di by dt plus E50t 50i is equal to 5 E50t. Then left hand side always maintain u into v formula, dy by dt E50t integrating factor, then I dependent variable, then 5E50t. Then equation separable variable differential E50ti is equal to 5E50t and then dt. Then integrate. So integral of derivative just 50t I is equal to integral of E50t, 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 then further integral, total derivative involved upon, so 5 upon 50, E50t, then plus C. Then further simplification, I E50t divide I is equal to 5 upon 50, 1 upon 10, then E50t divided by E50t cancel, then plus C, then you can write E power minus 50t, divide whole equation by exponential power 50t. So this is the situation of current at any time t. So in this way you will easily find the current at any time t as compared to use the general solution directly, which involve the complicated terms e power integral. So it is easy to use model of RL circuit, substitute the values of L, R, E, and then equation transform into simple linear form, then find integrating factor and multiply, then solve equation for current with respect to time t. So basically this is the required equation, current in the circuit at any time t. Now this involves one constant C, constant of integration. So after solving C, you can find current at any time t. Now general condition always exists when time 0, then current 0. The switch is off. The time 0, the quantity is 0. The time 0, the resistance is 0. Sometimes the conditions is defined. Say time 1 second, then current is 2 ampere and so on. So like this the condition is defined. Now here one statement involved and no initial current. And no initial current means the condition is time 0, then current 0. Definitely you can drive the one condition also, the time 0, then charge 0. Now sometime equation written in the form of the charge also. A question involving find the charge at any time t. So you can write the situation in terms of the charge. You know the current I can be written as dq by dt, rate of the charge with respect to time. So the question involving find the charge. So after this situation we write I is equal to dq by dt. So we get again differential equation separable variable form. Shift to the uh, dt to the right hand side, and then left hand side dq, and then again integrate, and then you will get the equation in terms of charge at any time t. So you know the current and charge are related to the equation. Say I is equal to dq by dt. So if I is given, then you can find dq by dt. Using dq by dt you can find the charge. If charge is given, then directly differentiate with respect to time, then you will get the current. So sometime data involve the finding the charge quantity, but we have the model in terms of the I. So use the model in terms of the I. After solving the I, change I into dq by dt, again integrate, again the model in the form of the first order linear separable variable form, and then simplify. Now the situation, finding the C applying the condition I0 is equal to 0, current 0, then charge 0, applying 0, 1 upon 10 plus C e power 0 1 times 0 e power 0 0. So C minus 1 upon 10. So this is information I of t 1 upon 10, then minus 1 upon 10 t minus 50t. Now you can predict the quantity of current at any time t. Put t is equal to 5 seconds, or t is equal to 1 minute, or t is equal to something, then you can find the current. Or you can put the quantity of the current, then you can find the time in which the current flowing in the circuit. So in too much detail I solve this circuit, and again the three points. First is the formation of the model, second is the general solution of the model, and third is the particular example. So I will assign you assignment in Google Classroom detail, but recall this. I assign the assignment as the application of first order linear ordinary differential equation, and the requirement is you write the title like RL circuit, then how to form the RL circuit, just like simple diagram, then the basic laws, Kirchhoff laws, then formation of the model. So the first one application, first part formation, second the general solution. I solved the problem by using the linear. Second part is the general solution, and third is the example. So you uh, write in all application of first order linear, the formation, general solution, and particular example. So I will assign you in detail Google Classroom how to submit the assignment, not now, just after completing our live session. of this application. Then after this, I will assign you assignment. Thank you.